Hey everyone, lesson 5 today, we're talking about the cosine function. We're going to look at the cosine function where the cosine matches the measure theta of an angle in standard position with the x-coordinate of a point on the unit circle. That's the point where the terminal side of an angle intersects the unit circle. So we're going to again use the properties of cosine functions. And recall that our amplitude A, that was the absolute value of that first number. The amplitude, we're going to draw that on our graph here. This is our amplitude, half the distance of the range, difference between the max and the min. So again, its amplitude is 1, and the period is the completion of one cycle. And again, here we're seeing that the period is 2 pi for the cosine curve. Notice how it's different than the sine curve, since our 5 key points are not starting at an intercept, but they're starting at a maximum and finishing at a maximum, and halfway in between is a minimum. So in between the maximum and the minimum, we have an intercept. And then again, in between the intercept and the maximum, we have another intercept. So our 5 key points go maximum, intercept, minimum, intercept, and maximum. Let's record that. So our first point is a maximum that occurs at 0, 1, and then an intercept that occurs at 90 degrees, or pi over 2, 0. The third point is going to be a minimum point. That minimum occurs at pi, negative 1, and then another intercept at 3 pi over 2, 0, and finally we're going to end with the maximum at 2 pi 1. In example 1, we're going to convert all of the values from 0 to 360. So like the definition said, the angle theta is the x-coordinate of the point. So the cosine at 0 degrees is 1, and the cosine of 30 degrees is square root of 3 over 2, that's 0.87. 60 degrees is a half, 90 degrees is 0, 180 is negative 1, 225 is negative 0.71, 270 is 0, 330 is 0.87, and 360 is 1. So converting those points to our graph on the second page is going to produce that parent function of the cosine curve. So at 0, 1, at 0, 1, we have a maximum, and at 360, 1, we have a maximum. At 180, there's a minimum. 90 is an intercept, and 270 is an intercept. So repeating that smooth curve, maximum, intercept, minimum, intercept, and maximum. We see one complete cycle, or the period of 2 pi. Moving on to example 2, we want to use the graph of the cosine function to answer the questions. We know that the amplitude is 1, the period is 2 pi, or 360 degrees. Because it's periodic, the domain is all reals, and the range ranges from negative 1 to positive 1, And if we wanted to estimate the cosine of 4, we know pi is 3.14. So 4 is going to be in here somewhere. And let's see. We'll say 4 is about, if this is -1, I guess we're about, what, 0.6 or 0.7? We'll guess at -6/10. And then using a calculator, so our guess is going to be cosine of 4 is about -6/10. And using our calculator, it's about, I guess, closer to 7/10 than 6/10. But we can take a guess. In example 3, we want to sketch the graph of 1.5 cosine 2 theta. So amplitude is our A value here. This is our A value, amplitude. So amplitude is 1.5, and it needs to be positive. And this is our B value. So our model is A cosine B theta. And the period is 2 pi divided by B. And if B is 2, then the period is pi. And here's the order of our key points. So we have an amplitude of 1.5, so we're going to start at a maximum, and we'll end at a maximum. I like to do the beginning and the end, so that sets it. We have a minimum in the middle, which would occur at pi over 2, so -1.5. And then our intercepts are in between, so an intercept at 1/4 pi and an intercept at 3/4 of a pi. Now, when you draw this curve, you want to be sure to draw a smooth curve and not a V, because you know it's going to continue on around. It's going to turn here as a maximum, intercept, minimum, intercept, maximum, and then it would turn the corner and continue to go. So our maximum is at 0, 1.5, intercept at 1/4 of a pi, a minimum at 90 degrees, -1.5, another intercept at 3/4 of a pi, and then the final maximum at pi and 1.5. So what did the 2 pi do? It shrunk up the period this way. Instead of it being 2 pi to complete one cycle, it shrinks it on the horizontal. For example 4, we want to write a cosine function with the description and choose that the A value is positive. So in the first example, if the amplitude is 4, and we're using that model, I'm just going to write our model over here. Y equals A cosine B theta. So we're following this model here, and this is our A value. And the period is 2 pi over B, and we've got to figure out the period is 6 pi. So if 2 pi over B is 6 pi, then the B value must be 1/3. And we know our A value is 4. So to write the equation using the model, y equals 4 cosine 1/3 theta. So this is our equation. For part B, same model, amplitude A is 2.5. So if A is 2.5, and the period 2 pi over B is going to be equal to 8, then B is going to be 2 pi over 8, which is pi over 4. So 2 pi over 8 is our B value. So pi over 4 is B. And using that model, y is 2.5 for the amplitude, cosine pi over 4 theta. So we can write equations for cosine curves. In the next example, if you want to take the time, you can grab a calculator that you're accustomed to using and graph the two equations. So in this example, we're going to find all the solutions on the interval from 0 to 2 pi. And if you look at my x-axis here, I've gone a little bit over 2 pi. So I would be thinking that this is 2 pi cutting off at 6.28 and starting at 0. So we're only considering between the two red vertical lines. And we want to find the solutions for 3 cosine 2t where it's equal to -2. So the way I'm going to approach that is I'm going to use the two equations. We're going to graph the left equation in the y1 screen, and we're going to graph the right side of the equal sign in the y2 screen. And you can see that down here in the picture. This is the y equals -2 down here. And this is the cosine of 2t with the amplitude of 3. So in order to be able to find where the solutions are, where they intersect, what I would want to do is I want to use the intersect feature. I'd have to do it 4 times to find the points where the two graphs intersect on the interval between 0. So remember what we're doing. We're looking between 0 and 2 pi. So we want all the places where the graph intersects, and you can see it's here 1, 2, 3, 4. So those 4 solutions I've written, highlighting them here, where they equal -2. So those 4 solutions are 1.150 and 1.991, 4.292, rounding up there, and 5.133. So these are the 4 places where our graph intersects between 0 and 2 pi. And then I'm going to erase that so you have a nice clean picture of that. Okay, and then our last example, we want to sketch one period of y equals 2 cosine 1/2 t, and our amplitude is 2. The period is 2 pi over b. There's our b value. So 2 pi divided by 1/2 gives the period 4 pi. And the amplitude would go between -2 and +2. Now to make this totally accurate, I would change my x-axis to be a t instead of an x. And we've got cosine, so we're going to have, the key points will be not in this order. This is the sine. So these are out of order. The key points would be maximum, intercept, minimum, intercept, maximum. So we need maximum, intercept, minimum, intercept, maximum. And that's out of place. So maximum at 2, and the end would be at 4 pi, so another maximum. And then halfway in between, we would have a minimum. In the first half, we need an intercept. In the second half, we need an intercept. And we need that smooth curve, max, intercept, min, intercept, max. So I hope your notes are right. We can put those points. Maximum is at 0, 2. Intercept is at pi, 0. Minimum is 2 pi, -2. And then intercept at 3 pi, 0. And maximum 4 pi, 2. And that finishes lesson 5 in unit 11.